morning. Good morning. Let's grab some seats here. Capuano, let's go. I'm waiting for you long enough.
Are you sufficiently whipped?
Not yet. Well, good morning. The ranking member and I have been discussing quite a bit about the emerging technologies that we continue to see across the not only across the country, but across the globe. And we wanted to hear from many of the different stakeholders from our community on what is being done, what is the status, some of the improvements that have already been made, and what do you basically see for the future. So not a long introduction. We hope to spend more time asking questions and hearing from you. With that, now I'd like to recognize the ranking member for as much time as he'd like to take.
Welcome, guys. Let's go.
Good enough. All right, do we have any other members that would like to make an opening statement? Seeing none, Lisa, if you would start us off here and make sure there's not anything official I've got to say. No, you're recognized. This is an informal roundtable.
Thank you very much. Thank you very much, Chairman Denham, and it's good to see you again, sir, as well as you.
You still owe us a train crash.
Yes.
I mean,
We still owe you a train crash, that is true.
Make that two.
Under controlled circumstances that can only happen at the Transportation Technology Center Incorporated out in Pueblo, Colorado. First of all, I'd like to thank you both for being able to come out last year. Certainly, I would like to invite you back again to come out and see the new things that we're doing, along with the rest of the committee. For those of you who have not had the opportunity to come out, I hope that you will consider coming out and visiting us in beautiful Pueblo, Colorado. Transportation Technology Center is an organization that is actually owned by the Federal Railroad Administration. And it's operated by my organization, Transportation Technology Center Incorporated. We employ more than 300 people, including over 100 research scientists and engineers. The facility itself is located in beautiful Pueblo, Colorado, on 52 square miles of secure, remote desert terrain where you can actually have trains impacting each other. We feature 48 miles of track, we have 4 bridges, and we have a world-class 5,000 square foot testing laboratory with hundreds of freight and passenger cars that we can use for simulations and testing. We're the home also of the Security and Emergency Response Training Center, which is known as CERTSI, and that has trained over 65,000 emergency responders since its inception in 1985 on its 600-acre response campus. TTCI and the Transportation Technology Center is a really great example of a working public-private partnership. The facility itself, as I said, is owned by the Federal Railroad Administration, and we operate the facility on its behalf. So as you talk about public-private partnerships and you want to see one that's working, this is one that has worked since 1982. I hope that you'll come out and be able to see that. We are the provider of choice we hope to be for advancing railroad safety and technology, and we'd like to be able to show you that in person. Thank you very much for having me here. I'm honored to be able to participate.
Thank you, Ms. Stabler. And again, we'd like to thank you for inviting us out and having the hospitality that you did last year, and we look forward to coming back. For those members that were not able to join us last year, the work that they do there is not only amazing from a safety standpoint, but also our first responders that get their training there. It is invaluable training, and we thank you for what you do every day.
Thank you.
With that, I'd now like to recognize Mr. Tennyson, CIO and Senior VP for Union Pacific Railroad Company. Mr. Tennyson, thank you for joining us.
Chairman, thank you. As you mentioned, I'm Lyndon Tennyson. I'm the Chief Information Officer at Union Pacific. I'm a technology guy. I kid that I'm the chief geek, but I'm with arguably the largest freight railroad in North America. I'm here hopefully to talk about some of the very exciting things that we're doing around both safety and efficiency from a technology perspective. I'll talk a little bit today about some of the work we're doing with vision systems to improve the inspection of our rolling stock. A lot of work we're doing along roadbed inspection using technology, and a number of other areas. I assume I'll get questions on that, so I'll kind of save my powder for then and pass it on to my other colleagues here at the table. But again, thank you for the opportunity, and I look forward to giving you some more information here.
Thank you. Also joining us, Seth Bodner, Chief Digital Officer with GE, and a veteran of several tours with the U.S. Army in Iraq, including Special Assistant to the Commanding General of the Multinational Force. Thank you for your service as well.
Thank you, sir. Thank you for your service. And thank you, Chairman Denham. Thank you, Ranking Member Capuano, other members of the subcommittee. It's an honor to be here, and we really appreciate the opportunity to participate on this panel. As most of you know, GE Transportation is one of the core industrial businesses at General Electric. We are a global leader in the production of heavy haul, diesel electric freight locomotives, and also a major supplier to the mining, marine and stationary power, and the drilling industries. We're about 10,000 employees strong, headquartered in Chicago, but with facilities, locomotive manufacturing facilities in Erie, Pennsylvania, as well as Fort Worth, Texas, plus our engine production and remanufacturing facilities in Grove City, which is also in Pennsylvania, as well as other plants and service locations around the world. We're incredibly proud to partner with our customers in the rail industry, an industry that is absolutely vital to this economy. And in today's environment, which is challenging, it's more important than ever that we partner together with our partners like Union Pacific and others to help them innovate, to help them compete. You know, we're proud that GE is building the cleanest, most efficient, most reliable heavy haul freight locomotives the world's ever seen. Our newest generation Tier 4 locomotive combines more than 200 sensors, generates 150,000 data points every minute to generate best-in-class power, fuel efficiency, and emissions. John, to my left here, told me he's driven many generations of GE locomotives. I won't tell you what he said about some of the older generations, but he did say these ones are pretty good. You know, they've gotten better. So we're really proud about what we're doing on the locomotive front. But as Mr. Tennyson would tell you, running a railroad is about a lot more than just a locomotive. And it's actually about a lot more than just track and infrastructure. To run a railroad effectively, you have to get the most out of that infrastructure, and one of the ways we're doing so is with cutting-edge digital technologies. So GE, as a company, has made a huge investment in digital capabilities. We've built out Predix, the world's first cloud-based operating system for industrial companies. And here in transportation, we've developed an entire suite of digital solutions to help our customers run their operations as efficiently, as safely, and as reliably as possible. And that's really in four main areas that I hope to spend some more time on. But it's about getting the most out of their assets, preventing failures before they occur. It's about running trains as efficiently as they can, you know, with solutions like our Trip Optimizer solution. It's about getting the most out of their networks, getting the most trains through that critical infrastructure of track. And we do that with solutions like our Movement Planner solution. And then it's about more effectively interfacing with that broader supply chain, that broader freight ecosystem. And I'm excited to talk about some of the work we're doing with the Port of LA in optimizing throughput through that critical node in the supply chain. These solutions that we've developed are delivering real outcomes. I mean, every week, Union Pacific and our other customers save an estimated 800,000 gallons of fuel with the Trip Optimizer solution by driving their trains more efficiently. And I'm really excited, obviously, about these solutions and happy to talk about what we're doing together with our partners across the industry. Thank you.
Thank you. Also joining us is Mr. John Rich, National Legislative Director for SMART, that's Sheet Metal Air Rail Transportation. He has spent a great deal of time on some of our trips on the road up in North Dakota in his home state, as well as elsewhere as we've traveled to look at safety technology and also some of the labor issues. Mr. Rich, thank you for joining us.
Mr. Chairman, thank you. Ranking Member Capiano and other members of the committee, it's an honor to be here today. And first of all, I'd like to say, Seth, yes, I have operated the GE locomotives, and they were behind this, the model of the best when I started, but they turned into some of the best, if not the best locomotives that I operated when I was working for the Burlington Northern Santa Fe, now the BNSF Railroad. May 15th of this year, I'll have 40 years in the industry. I started in 1977 in the track department. And when I started in the track department, I started on a tie gang. I was in college and we were replacing ties, and we had between, depending on the gang, 35 to 50 people on the gang. And when I talked to my foreman, I said, he told me that when he started in tie gangs, early in his career, there were 300 people on a tie gang. We went from 300 to probably average 40, and both of those tie gangs put in about 1,000 ties a day. Technology improvements reduced manpower, increased safety, made things much more efficient. In 1978, I became a trainman on the then Burlington Northern Railroad, now the BNSF. And we had 5 people on a crew, on a train. 3 on the front end, 2 on the rear end. We had a caboose. We had 100 coal cars. They were steel coal cars. We went 100 miles. And we were lucky to go out 100 miles in 10 hours or such. When I left to come out here to Washington, D.C. in 2009, instead of 100 cars, there were 126 cars. Instead of steel cars, there were aluminum cars. Instead of going 100 miles, we went 200 miles. Instead of 5 people on the train, we had 2 people on the train. So technology, I've seen a lot of it over the years. A lot of it has helped in regards to safety. We've got a safer rail industry because of technology, because of a changing safety culture, and because of regulations that require the railroads on certain ways to operate their systems and their trains more safely. Today, I'd like to speak about, and we can, as this proceeds forward, what I think is the greatest technological advancement I've witnessed in my 40 years in the industry, and that's electronically controlled pneumatic brake systems. I operated electronically controlled brake trains, coal trains on the BNSF in North Dakota. They are incredible. They will slow and stop trains as much as 70% faster than conventional brakes. Conventional brakes have kind of reached the end of their advancements. We went from AB brake valves to ABD to ABDW, and they've reached the end of their technological improvements. ECP brakes, on the other hand, have a long ways to go and can do incredible things. And as we proceed forward, I'll touch off on a lot of things on what ECP brakes can do and could do for the future if we continue down that path. But thank you again, Mr. Chairman.
Thank you. This is meant to be an informal roundtable. It is similar to a hearing. We will allow each member to ask questions as well as follow-up questions, but this is really an opportunity for us to get a better understanding of new technologies that are out there, as well as the priorities of the industry on how we move forward on specific technologies and how many new things can we actually do at once. Mr. Tennyson, the biggest issue that comes up in my district, when you've got districts that are both urban and rural, I have ACE train that goes through my district that's on UP tracks, oftentimes going through urban areas, which you could have somebody that's got a set of headphones walking across the tracks, or somebody that's not paying attention. As well as in urban areas of my districts, we've got rail crossings where you could have a hay trailer or something stuck, or a farm equipment that is stuck on the tracks as well. I wonder if you could explain to us some of the technologies that you're using just to avoid some of these collisions where somebody may not be paying attention or may be stuck on a rail crossing.
So let me talk for a little bit about the rail crossings. One of the things that we've done, you hear a lot in the press today about big data, but one of the things that we've done, we consciously started doing a couple of years ago and have really accelerated recently, is something we call our CAP program, which is looking at the high-risk crossings and trying to analyze those using big data. So we not only use the data that we have internally that has a lot of close call information that's reported from our crews and from other technologies that we have, like our forward-facing cameras, but we use a lot of other information that comes from highway departments and others, and we bring all that into a very comprehensive data analytics environment, and it helps us to identify those crossings that we believe have the highest probability of a collision or of an impact, and then we work with local jurisdictions to try to either close those or guarantee that they have maximum protection and other things like that. And so we've seen increasing improvement in our grade crossing incidents because of our focus on that, and I think we'll continue to see it as we leverage this technology more. So that's one of the things, for example, that we're heavily investing in to try to minimize the impact of these grade crossing incidents, or to try to eliminate them.
Thank you. Anything others would like to add on grade crossings, or?
Well, I guess the one thing is continue to have at least 2 sets of eyes in the lead locomotive of the train to watch out for someone crossing the tracks, where you can alert them by whistle at least, to try and, when they have the headphones on, if you don't blow the whistle, it's not likely they're going to see you or hear you. So.
Thank you. Mr. Capuano.
Thanks, Mr. Chairman. First of all, I want to thank you all for being here, and I want to apologize. Like many of us, I'm going to have to run in and out today, and I apologize for that. And I also want to add my thanks, Ms. Dable. I really did learn a lot on that trip. I really did. I was really impressed by it. And oftentimes when I find things I'm impressed with, I try to convince people to come to Boston. We can't accommodate you. We don't have 52 square miles of anything, so we love you, but you're going to have to stay in Pueblo. You know, GE, on the other hand, you know, Union Pacific, you guys are welcome anytime.
Well, as you know,
I do.
we actually just located our headquarters in Boston. So
Very
we,
intelligent move.
we
It
took
clearly
your-
tells
we
me
took
you're
your
led by
welcome very
thoughtful,
seriously.
insightful people. I kind of want to ask 2 questions, and I actually appreciate the chairman's first question. I've been trying to focus a little bit at grade stuff myself, because it strikes me as, number one, as far as I know, that's the place that more people get killed than any place else on railroads. And it continues, and it's low tech, as far as the stuff that I know, is relatively low-tech stuff to improve. I know it's expensive on occasion, but not that expensive compared to some of the other things that they're doing. But I guess what I really want to ask, since this is about technology, I really appreciate the fact that a relatively older technology, trains, is modernizing and catching up, because new technology can help you, as you all know. And I think that's fantastic. I love it. I think it's going to help everybody around the board. But I also know that there's all kinds of technology. Some of it is 40 years out and thoughtful, and some of it is ready now. And I guess I'd just like to ask each of you, and I'm not sure that I can address this question to you, Ms. Stable, but I will if it's appropriate. What's your next great technology that you think is usable? Not the ones not the greatest technology that won't be ready for 10 years. That's a different question. But the ones you think you're going to be able to, deploy and use and save lives or save money or save equipment, whatever it is you're going to do with it, in the not too distant future. What do you think is the next great improvement done in the rail world?
Well, given that you're talking about the next great improvement, I would have to say that drone technology is probably the game changer that is closest to full implementation, and yet can also provide a real game changer for the industry. If you look, certainly some of the railroads are farther ahead on that journey than others at this point in time. But drones can really work in a number of different areas. And the first one is to help reduce the risk associated with inspections that we have to make. If you want to think about it, think about being in a cherry picker off of the side of a bridge trying to look to make those inspections. Drones can do those same types of inspections and reduce the risk associated with having an employee in that particular environment. Now, obviously, you still have to make the repairs if they find something, but at least you can help reduce risk.
Things what's the best use of a drone for a rail company?
For that, it's to augment what people can see. So if I can see it with my human eyes, I can also see it with the cameras that are associated with the drones. So those types of inspections that an employee can make with their eyes are the same types of things that we can do with drones, and we're really only just beginning on that. The other area, though, when you move outside of inspections for track and track structures primarily, is in emergency response. If you have a situation now where you have an incident and you have some sort of release of a chemical, you need to assess whether or not there's a problem. How much has been released? What's the situation really look like? What we do now is put humans in hazmat suits and send them as safely as we can to try to make that assessment. What we're looking at is the possibility that you can have a drone take remote sensor technology and deploy it near to the derailment, fly over the derailments and see what's happening, to allow them to make the assessment of how best to remediate the situation without putting those emergency responders at risk. That's something that my organization is going to be using later on this year. We're augmenting our training classes to try to be able to involve use of drones for first responders.
Great, thank you. What about you, Mr. Tennyson?
Yeah, if I can maybe expand on that. The first two applications that we made with the FAA actually for drone technology were exactly the first two she mentioned, which was inserting a drone into a hazardous spill location to do an inspection prior to sending a human being in, like in a hazmat suit. And we're already working through the protocols to do that. And then the second one really is bridge and tower inspection. And so I think those are fairly near in. I think actually, though, for us, a larger impact is sensor technology, what's going on in the space, in the area of sensor technology. And also with video, what's happening with video and things like laser and LiDAR. For example, I have a picture I'll show you here. You may or may not be able to see that. This is an example of one of our...
We saw something like that out.
This is one of our portals. We have 3 of these deployed currently, 1 in production, 2 in R&D, where we're able to basically film a train at speed, 60 miles an hour. We bring in about 500 billion pixels of information. We have literally a data center that sits trackside right beside that portal. And we're analyzing to 1/1000th of an inch defects on rail cars and things like that. We also have and it's a full 360 look, and it's a combination of video, laser, LiDAR, infrared technology, and a number of other things. I think that sensor technology is going to fundamentally change our inspection processes, the timeliness of our inspection processes, the method we go about, and the relative safety that we can see from the inspection process. And we're investing significantly in this. This, for us, we think is a game changer. And so we have probably nearly 100 engineers working full-time on this type of technology and are spending millions of dollars, actually tens of millions of dollars per site to deploy this and test this out. The other thing that I think consistent with that also will drive, when I say sensor technology, is just the lower cost technologies. This is another example I have of something that we actually designed internally at Union Pacific and had manufactured. You can see the relative size. This is the size of a quarter. We can insert 8 of these physically into the track itself and do the equivalent. Lisa will be familiar with this. We have today what's called a wheel impact load detector. It's a piece of very sophisticated, very expensive technology that can look at things like the impact on the rail, the weight on the rail. You can look for out of balance rail cars, et cetera. This technology, we can produce the equivalent of a wild site for about $10,000 versus something that's maybe a $3 or $4 million per site. We think in the next 5 to 10 years, we'll be able to deploy these roughly every 2 miles on our railroad and be able to do the equivalent of what today a $3 or $4 million wild site would do. This is the kind of stuff, again, we're investing in. So I think the sensor technology and things like video and lasers are going to make a fundamental change in what's going on in the space. And I could go into more detail. I want to kind of stop and let you ask some questions. Huh?
You're having way too much fun.
Well, this is what's kept me in the industry for 24 years. I came into this industry out of airlines and always in technology, but this is what's kept me in this industry has been the investment that we've made and the very challenging problems that we have, which we're investing in to try to overcome.
What about you, Mr. Bodden? You got any toys?
Yes, sir. We of course we do, and we're really excited. You know, as GE, we look across multiple industry. We look across multiple modes of transport. I think what's so interesting about the rail industry is it is by far the most fuel efficient way to move goods across land. It's fundamental to the economy. I think that one of the biggest challenges that the rail industry faces is not necessarily cost. It's reliability and predictability. You know, how do you reduce variation in the delivery of goods from point A to point B? And I preface that because solving that problem, I think, is fundamental to driving growth in the rail industry, driving growth in our economy by ensuring that we have continue to have the world's most efficient freight transportation networks. And the way we do that is both, I think, with sensors, but the integration of hardware together with software to connect what are today disparate systems. And let me give you an example. So we build locomotives. Today, with the data and analytics capabilities we have, our latest Tier 4 locomotive, we have data about how that locomotive was designed, how it was configured, how it came out of our shops, how it's been used in service. We can build what effectively you'd call a digital twin of that asset. So when we're gathering data with our customers from that asset in real time, we can make some pretty precise predictions about what might happen to that locomotive in the future so you can avoid an unplanned failure. As Lyndon would tell you, when a locomotive fails on a track, you can't route around it. It gums up the whole network for hours, days, sometimes even weeks. So avoiding unplanned failures at the asset level. And then you zoom out and you think about the train. I talked about Trip Optimizer. We have, which is think of it as a cruise control system for a train. Helps the engineer drive that train in the most fuel efficient manner. Systems like low control distributed power that enable longer trains. Those are great for building efficient trains. But if you don't understand the health of the asset, you can be driving an efficient train and have a failure that you don't expect. And if you zoom out from the train and you think about the network, a fuel-efficient train is not all that effective if it sits in a gummed-up network. So solutions that we've developed now with and are implementing at our second Class 1 railroad called Movement Planner, which you can think of it as an air traffic control system for a railroad that optimizes the meet pass decisions for trains around the network to get more trains through that same track. And so those are three solutions, and they're all impactful. But when you have them talk together, and I know about, hey, this locomotive A, the lead locomotive on this train is sick, for lack of a better term. I can adapt my Trip Optimizer algorithm to make sure that, hey, I'm not pushing that locomotive beyond its failure, or excuse me, beyond its current capabilities. And if I zoom out to the network, if I know from our Movement Planner solution that a train's going to sit and wait in a siding, I can slow that train down and save even more fuel. And I can run that whole network more seamlessly to make rail a more predictable, reliable means of transport. And that's, I
Have you
think...
worked with the Volpe Center at all on some of this stuff? Because that's kind of exactly the stuff they do with trucks and planes and boats. I'm not sure about trains, but I assume...
You know, I'll be honest, I'm not as familiar with the Volpe Center, but we'll
We'll educate you. They're in Boston, too.
All right. Right next door to us, then. All right.
What about you, John?
Well, I guess the original question, your question was, where can we make the big leap forward? What's available today? What's taking place? I've seen great advancements with wayside detector technology. Originally, they started with just dragging equipment. If you had something dragging from a car, it would warn the train and send off an alert. Then it evolved to heat sensors, which could sense a warm bearing. And now the latest ones actually will listen for bearings that are making noise or something wrong with the car, and even take pictures, I think was mentioned. Right outside of Bismarck, North Dakota, this detector, when I go by with the train, I'd pull my train by it at 60 miles an hour. At night, you could look back in the curve, and it looked like a strobe light. They were actually taking a picture of every truck on the train. And when you got to the terminal, the car repair facility, the carmen, if they heard some sort of noise, would look at that picture before they went out and inspected the train. So we've come a long ways with detectors. But the answer to the question, the big leap forward, the very foundation for increases in safety and improvement in the rail industry, I believe, is electronically controlled pneumatic brakes. And I might sound like a broken wheel, but that is the foundation.
If you were a broken
for the
wheel,
future.
they'd find it. Don't worry.
Right, because with electronic brakes, the crew in the engine can monitor every car in the train in real time, whether or not it is functioning properly. Plus, it stores retrievable data. What happens is the federal rules require that trains are inspected manually every 1,000 miles, sometimes 1,500 miles on extended haul trains, and some have exceptions up to 1,800 miles. I pull into the train station with my train, the carmen inspect the train, and they find a car that the brakes don't apply. We switch the car out, it goes over the car shop, sits in a warm shop overnight. The next morning, the carman will test it. Oh, the brakes work now that it's in a warm shop. It just gets sent back out on the train. With ECP brakes, there's a computer box in there where you can actually determine whether or not the car applied and released every time it was possible. ECP brakes would have prevented the Lochmananic accident in Canada. And it would have prevented it because, and you can read Transport Canada's report from 2013, because when you have electronically controlled pneumatic brakes, whenever the brake pipe pressure on a car drops below 50 psi, the car automatically goes into emergency. So even if we have a train crew that fails to secure their train properly, for whatever reason, ECP brakes will prevent that train from running away. But some of the greatest things, what I think is the greatest aspect of electronically controlled pneumatic brakes, is something called the graduated release. I used to operate coal trains in very heavy grade at temperatures as low as 40 below zero. And coming down these very long grades, you had to plan as an engineer to apply, and then whenever you needed to release the brakes on a conventional air brake system, you have to release it fully. And once you release it, you need time to recharge that brake system. In very cold weather, the air is very thin, and it takes much longer to get your air brakes system back up to where it's effective again. With ECP brakes, you can partially release the air brake system, and your brake system is charged at 100% all the time. Now, the railroad industry in their opposition to ECP brakes say, well, we have distributive power. We have engines on both sides of the train, which helps in braking because it exhausts the brake pipe pressure from both ends. Plus, it helps in charging the train, keeping the train charged with air brake pressure. And that's absolutely true. But it doesn't compare to electronically controlled pneumatic brakes that keeps it charged 100% of the time, all the time, allows for a graduated release and the ability to monitor every car in real time and see what that car was doing when it comes into the facility. Eventually, ECB brakes can evolve to the point to do all the things that these wayside detectors do. They will be able to listen for flat spots on a wheel. They'll be able to listen for bearings that are not operating properly. It's really the foundation for the future. And if we want to improve rail safety in a big way to get to the point where the airline industry is today, it's ECP brakes.
Gosh, how much time do we have? John, I'm going to come right back to you, if I may, on the ECB brakes. There's so many questions there. These are pneumatic brakes that you're talking about, electronic signal that actually applies or sends a low voltage to a transformed voltage mechanism that applies the actuator that opens up those pads, allows the pneumatic air to flow in, and opens up those pads and cause those brakes to expand and hopefully slow down the car. You said that there's a little circuit board there, we call it a printed circuit board or brain, electronic board, whatever, computer board, right at each individual wheel. Is that the way it works?
Each individual car.
Each individual car. So is there a centralized electronic board that sends a signal to, is there going to be, how many wheels on each car would you guess? Is there going to be 10, 12?
4 sets of wheels.
4
So
sets.
You could call it 8.
8 wheels, okay. So you said it knows if the brakes were applied.
That's correct. You'll have there's a screen and I operated these trains. There's a screen in the cab of the locomotive that tells you which train brakes are applied and which ones are released.
Does it know if they weren't applied? Does it know why not?
Not at this point, but certainly if they don't apply, then that car would need to be inspected when it came into the next terminal.
So on your example where they took the car offline, they got it, the weather was cold, for whatever reason it didn't happen, does it have a temperature range variation that it sends a warning signal to the engineer?
Well, they don't have the temperature warnings now, but that's where the evolution of ECP brakes do. But what would happen when the train got to the repair facility is this. The carman could plug in their module to find out which cars were not operating properly. So that car that didn't apply, the carman would know. So it would be taken out and repaired and looked at more thoroughly, compared to what happens now where you just come into the terminal, they look at the car, if it applies, well, it must have applied and released properly all the time, but we really don't know that, but with ECP we would.
Does the single module per car allow you to determine of the 8 wheels, which, if only one of the brakes failed or 2 of the brakes failed, does the module know?
Well, I don't think the current technology tells you which wheels apply and there's 2 separate trucks on the car.
Okay.
But certainly we could evolve to figure out which one it was.
Is it capable? I'm assuming I'm thinking of brake check, Mr. Chairman, where you've got pads or now disc brakes. We had those old pads.
Yeah, they've got pads now.
They've got pads made of what, do you know? Does the
Composite material of some sort,
Gotcha.
which used to be steel.
It used to be asbestos many, many years ago.
Asbestos. It went from steel to
I'm
asbestos.
old. And she's laughing because she knows I'm old. So we had that discussion, right? So can it monitor the pad thickness as well?
Not the pad thickness, I don't imagine.
Okay. Pretty technical questions, and
Oh, good question.
yeah, I'll yield back for the time being, Mr. Chairman. I've got a lot of other questions, so, yeah.
Thank you, Mr. Chairman, and for the witnesses, thank you so very much. The discussion on the electronic controlled pneumatic brakes, very good. So why isn't it happening? UP? Lisa?
I kind of wish I had my chief operating officer here, but I'll try to address it as best I can. For us, he mentioned that we think that today we get largely the same safety coverage with distributed power, and we've continued to roll out. In fact, the preponderance of our trains actually operate under distributed power, and we've continued to roll that out. There's also some issues from the standpoint of an implementation of ECP brakes, because it's really kind of a revolutionary change as opposed to being a very evolutionary change, and it's difficult for us to go back and retrofit everything. And then in addition, with the work that we're doing, one of the other things that comes into consideration is with the work we're doing with PTC, we've tested some ECP, and there are some issues with us. It just adds some complexity to our PTC implementation. But I think the real issue is we believe we get the preponderance of the safety coverage with our current distributed power implementations.
I suppose that'll be determined, Lisa?
I think in addition, many of the things that Mr. Risch talked about can come true with onboard diagnostics. And the fact that the ECP system actually is present or could be present now does not necessarily mean that onboard diagnostics could also not be present and do many of the things that he was describing. Being able to have sensors on the various places on the freight cars or passenger cars that look for the conditions that we see with wayside detection. But I don't know that that necessarily requires that there's an ECP platform for that to happen. It does require onboard diagnostics. It does require an onboard computer.
Could I take?
Sure.
Could I expand? I apologize. Nearly 7 years ago, we started an industry initiative led by Union Pacific, but we involved all of the railroads, where we looked at a technology at the time we called MOATS technology. And what it was really the direction that was being led to, which was a set of sensors on the actual rail car itself that was a combination of things like an infrared heat sensor, an accelerometer to look for vibration or other types of effects. We could have even included things like pressure gauges for looking at things like hazardous cars or cars that were under pressure. We are continuing to test that technology. There are some implementation issues with it. Power is one of the issues. The cost of implementation, just from the standpoint of the manufacturing of the actual sensors and their survivability and things like that. But we have invested a significant amount, multi-million dollars in the industry evaluating these modes. So I think where Lisa's heading is, I think that gets back to my point that I think the sensor technology, as the price points continue to come down, as the survivability continues to grow, will offer us new capabilities to be able to do a more continuous monitoring of these assets, which will continue to drive continued safety. And then the other piece of that is bringing that information back and being able to do analytics on it, complex analytics on it.
It seems to me that we have an issue here of the bottom line is cost, one versus the other. And I'm wondering if it's not time to do a study to determine, because I've heard this issue for the last 3 or 4 years, about the relative cost of doing with a electronic controlled brake system versus a engine on either end. What's the difference in cost? What are we talking about? Also, there's a phase-in implementation, apparently, because Mr. Risch has already driven trains that have these systems in place, so it's not unknown. I think we ought to pursue that. Do you have something to add, Mr. Risch?
Well, if I could just add the cost. The experts that I've consulted with, it's about $3,000 to equip a car with ECP brakes. The new 117 tank cars that are being required by the FAST Act cost $144,000 to produce. So $3,000 is not insignificant, but it's in relationship to a $144,000 car. It's not crazy either. The locomotives, I'm told, cost about $60,000. But keep in mind the requirements, the PHMSA rule requirements for ECP brakes on hazardous material unit trains. Those are unit trains. They stick together, they hang together, the cars are together. The ECP trains I operated were unit trains, and they were fantastic. I once overlooked a slow order. I'm driving my coal train at 50 miles an hour, and I thought, whoa, I got a 25-mile-an-hour slow order, and I could see the flag out in front of me. Immediately, I applied the brakes, and with ECP brakes, you eliminate in-train forces because they all apply and release at the same time. Just like this, down to 25 miles an hour, partially backed it off, stayed right at 25 miles an hour. With a conventional train, had I tried that, I could have put the train in the ditch because when I start applying the brakes, the cars run in, they could kick out to the sides. So the cost is something. It's out there. They know how much the cost is. The industry does. They've had ECP trains out there. It's the implementation. I think the PHMSA rule was a fair, reasonable 2021.
Well, it seems to me we ought to dial down and see what we're talking about here. The safety issue, we'd love to see some more of that. I want to switch to one other issue, and that is the positive train control system. As I understand it, is dependent upon GPS. Is that the case?
It utilizes it. It has a significant, a lot of other aspects in terms of being able to understand where it's physically located at. We use GPS a lot. But GPS for us is not enough to refine discretely to the exact track that we're on, like if we're on track 1 or track 2 when we're in parallel tracks locations. So we have some additional technology that we leverage. But maybe I should ask for more for the reason for the question.
Well, the reason for the question is that we know that GPS is the single point of failure for everything we do, period. From ATM machines to cell phones, all of that is dependent upon GPS. And my understanding is that for the positive train control system to work, it too is dependent upon GPS, perhaps not in totality. The point is we have no backup. There is no backup for GPS. It is possible. It is not a big deal. It is called ELRAN. And it would provide both timing, positioning, and navigation when fully built out. But the timing could be done very, very cheaply and could be utilized across every part of the American, or actually the world economy, but particularly here for terrestrial United States. So I bring that as point of discussion for further use. I'll share it with the chairman and the ranking member and anybody else that's interested in it. It is a critical backup system that is essential. Might point out for national defense issues, one might wonder why China and Russia have built a Lorraine system, because they know that in a conflict, the first thing to go is GPS. And it's not just a national system. You can buy a GPS system, a system that would degrade GPS on the black market, very cheap, that would cause your
I think that's the reason we
control.
haven't relied on GPS from the standpoint of a safety-sensitive operation currently anyway, because not only for those reasons, but because of the resolution was not adequate for us to drive safety-sensitive operations.
So anyway, I want to put that on the table.
It is good. I think we should follow up on that. I'd love to follow up on that and get some of our folks involved in that.
Good. I yield back my time.
Thank you, Mr. Chairman. Good morning. As a new member of both of the larger committee, T&I, and of this subcommittee, I'm really pleased to be here, and just fascinating for me. This is all new, so fascinating for me to learn about the industry and look forward to continuing to do that. The only question I have today, we're talking about safety, and this is an issue that I've heard about in my district, and while you're here, I'd like to get your comments, and that is, we have a freight line that carries crude oil, so obviously very long trains with highly flammable material, and so this periodically is an issue for constituents of mine. We get asked about this, particularly, I think you mentioned the accident in Quebec, particularly after that raised the awareness. And so I guess I'd like to hear from you the status of the safety of transporting crude oil, what we've done in response to the accident that occurred, and whether there are still additional things that we're working on.
I'm actually from North Dakota, the Bakken area. PHMSA, the Pipeline Safety Administration, passed rules last year for stronger tank cars for the transporting crude oil. The Federal Railroad Administration also enacted an emergency order requiring better standards for securing crude oil trains, and they're to be operated as, in the industry, we call key trains, and we operate them at slower speeds. We're careful when we pass another train or we take a siding to meet another train. And in addition to that, there's a requirement that unit crude oil trains by 2021 be equipped with electronically controlled pneumatic brakes, because they're the safest brakes in the world. In fact, the Association of American Railroads require electronically controlled pneumatic brakes on their nuclear waste trains. So that's not a federal rule, it's a AAR standard. So we've come a long ways. My home state of North Dakota also enacted rules reducing the volatility of the crude oil before it's loaded into the tank cars. I think the path we're down is making crude oil transport far safer, and we look forward to hauling lots more of it because we've got a lot of railroad workers that need jobs.
The first thing you mentioned was the tank itself.
Oh, yes.
So are you, so what, tell me a little bit more about that, and has that already been implemented, or is that something we're still working on?
It's being phased in the new car standards, which the rail industry has requested for years, and it took a long time to get the new car standards. And the rail industry themselves demanded very high standards for these cars, thicker jackets, better couplers, protections on the valves, things of that nature. But they're stronger standards enacted by PHMSA, and they're being phased in. Of course, you know, you can't build 100,000 rail cars overnight, and they're producing some of these rail cars. And at the same time, the shipment of crude oil by rail is diminished tremendously. We used to ship 10 to 12 trains a day out of North Dakota, and now we're down to 3 or 4 because the pipelines have taken over the transport.
So that trend, I guess, will continue to occur. More and more will be done by pipelines as opposed to rail.
Well, we hope not.
Yeah, yeah. Well, you brought it up. What would you say in terms, again, in my county, it's basically these trains are just going through the county. What would be the greatest risk for transporting? Like, if there is going to be some sort of failure, what would cause that? What concerns should we have? Or you've already addressed what we're doing, but I guess I'm looking for the areas where we would see the greatest risk in terms of the transportation.
Well, first of all, transportation by train is very safe.
Sure.
It's unusual.
I understand that.
Unfortunately, we had some terrible accidents with these crude oil trains, and it surprised a lot of people that they were as flammable as they were. You know, crude oil, you think of, you know, when I think of on the farm, I've got diesel fuel that you got to practically hard to ignite even. Crude oil, I thought, was less so, but this is very, was pretty volatile, and we're working on that. The greatest threat, I suspect, is a derailment or a possible head-on collision. Positive train control prevents most head-on collisions, and that's being implemented in 2018 or to 2020, so that'll help depending on what line you're on. So that'll be helpful. There's all kinds of technology advances that these people can talk to as far as monitoring the track's conditions and things of that nature. Maybe, Lisa, you want to take off on that?
Thank you, yes. Certainly, as Mr. Rich said, one of the things that you can do is to make the tank car more resistant to failing in an accident. And the DOT 117 tank car has a number of improvements that are in there, including a full-height, half-inch thick head shield, the tank shell thickness that is 9/16 of an inch minimum. It has additional thermal protection, 11-gauge jacket is on there, better top fitting protection, and enhanced bottom outlet protection as well. So the tank car itself, first of all, is better able with the new DOT 117 to withstand the event that we all hope doesn't happen. In fact, when you look at our organization, that's the purpose of TTCI, is to figure out how can we prevent derailments from happening in the first place, or if there's an issue, how can we detect them before they become a problem. So our organization looking at better ways to be able to prevent broken wheels, broken axles, broken rail, make certain they don't happen in the first place. And then secondly, for that infrastructure that's out there, to make sure that we are able to find those conditions well up front and remediate them before they become a problem. If you look, I joined the BNSF, in fact, back in 2000 and then TTCI in 2010. Since 2000, when I came into the industry, is kind of the point that I like to start with, there's been a 65% improvement in rolling stock and track structure related derailments. And it's been because of the work that we've been able to do, as well as the work that the industry has been able to do. The railroads, the manufacturers, our union partners have the same idea. 0 is the only acceptable number, and we won't be satisfied until we get there.
Thank you.
Thank you.
Mr.
That's-
Smucker.
Appreciate it.
Ms. Wilson.
Good morning, and thank you. I'm from Miami, Florida, and when Miami was founded, there were about 300 people living there, and there was just beach and sand. And then the Flagler Railroad began construction, and many people came from the Caribbean islands. My grandfather came from the Bahamas to help build the railroad. And as the railroad grew and blossomed, so did Miami. So the railroad was like the basis of starting this very global, wonderful city that we all know now. And I grew up to become a school principal. And the railroad ran behind the school. And if you think about it, in many of our cities, you'll find that the railroad, during the days of segregation and Jim Crow, the railroad was the dividing line for white town and black town. And so when you would ask kids, where do you live? They say, I live across the tracks. And that was the way that it was. So many students coming to my little elementary school, maybe about 8, were killed trying to cross the railroad, not at the street, but coming through neighborhoods and coming out of fences and taking shortcuts. They would call it across the railroad track, and then a shortcut into the school, and they didn't see the train. The train didn't see them, and of course, it was a disaster. So when All Aboard Florida came to see me in Miami, and we began to talk about building the railroad, they're using the same tracks that were used when I was a school principal, and those schools are still there. So that was a great concern for me, the safety of the community, the safety of the kids, the safety of how are they going to cross, how are they going to navigate through the communities, what would the speed limit be when they actually, so it's, a population boom now, so these trains go through actual communities. So I'm hoping that all of us in this committee will work towards making it very safe for these railroads, and especially for the people who live in those communities as they try to navigate across the tracks. So the deadline for positive train control implementation has been extended to December 31st. Do you expect the rail industry to meet this deadline? If not, what are some of the challenges for meeting that deadline? That's my first question. And looking forward as we educate future rail industry employees, do you see specific educational or personnel shortfalls that need to be addressed, especially in the line of safety?
Go ahead. Well, let me talk just a little bit about the challenges, and then I think Mr. Tennyson from Union Pacific, who's organization is actually one of those responsible for implementation, can talk about that. The challenge with PTC is essentially we've had to engineer this system from nothing in 2008 after the Rail Improvement Safety Act was put in place. There were efforts before that act was put in place by individual organizations to have positive train control. But with that act, it really changed everything because everyone has to have a system that can be fully interoperative with each other. So that caused a lot of organizations to have to scrap what they did and really begin again to design and engineer a very, very complex system and then be able to manufacture the devices that were necessary to go on locomotives, on about 100,000 miles of track, to put base stations in place and all of the other things associated with that. I know that from TTCI's perspective, our job is to help determine, for example, where and how to best implement interoperable train operations, especially in large cities. But it's a very complex system, and at this point in time, it is the physical implementation that has to be accomplished. Lyndon?
I can't speak for the entire industry, though I can give you sort of a gut feel opinion, but I can talk for Union Pacific specifically. We are committed to be implemented before December of 2018. In fact, our current implementation plan has us wrapping up our last subdivision in roughly September of 2018. We cut over our 31st subdivision this week out of about roughly 136 that we have to cut over. We're on a very aggressive pace to cut over those subdivisions. So we're committed to try to get there. It's definitely been a challenging implementation. Lisa touched on some of the issues. You know, we were installing gear before we had ever really run a full test of the environment. So we were installing Revision 1 technology, and we'd never really had a chance to proof out Revision 1 technology. So that added complexity to a lot of the implementation. But we're feeling pretty good with where we're at today as a railroad. I think there are others who are further behind, but I don't hear anything in the industry where anybody's saying that they're not going to still try to make the December 2018 date. But I know for us, from a Union Pacific perspective, we're absolutely committed to be installed by December of 2018. And we've spent roughly $2.1 billion to date. We'll wrap up a little under $3 billion to be fully implemented, and we're making the financial commitments. We're absolutely committed to be there.
Thank you, Ms. Wilson. Mr. Webster.
Thank you, Mr. Chairman. I have a question for Ms. Stabler. In how much of a percentage would you say, or if you do at all, maybe you've already said that, how much do you use simulation, any kind of the simulation industry?
In fact, simulations and computer models are really the heart and soul of what we do. If you look, and I know that Chairman Denham would love to come out and see trains crashing into each other or tank cars being punctured, and we're going to somehow figure out how to make that happen here some point in the future. But the reason that we run those tests isn't to be able to test that particular design. The reason that we run those tests is to be able to validate computer models that we have as an industry that look at things like how strong the design is, how that freight car is going to interact with track, how the in-train forces in a train are going to react to be able to stop the train, how long it takes. So there are a number of different computer programs that we have. Some have been developed at TTCI and are available for the industry. Some are used widely, such as finite element analysis, that a lot of different organizations have. But overall, when you look at how do you do designs for any kind of complex product, to be able to have computer models that accurately represent what's going to happen in revenue service or in a field environment is key and critical. And the testing that we do, for the most part, is meant to validate those models so we can run millions of simulations and be able to come up with the best solutions in a very short period of time.
So do you take the information you get from the actual real-time crash or whatever and perfect those simulation programs?
Yes, in fact, for example, like with a tank car impact, we have an impact wall at TTC where we can take a tank car and put it up against the wall and then impact it with a known size impactor at a very precise speed. Generally, we can control within about 1/10 of a mile per hour. So we'll run tests in conjunction, in fact, with, I wish Mr. Capuano was still here, because we do work with the Volpe Center, to be able to validate a computer model. So we'll have a particular situation that we'll set up, and we'll impact that tank car at a particular speed, and we believe, for example, at that speed it should be punctured or it should not. And then that's when we see what the results are, and also have hundreds of sensors, dozens of cameras set up so that we can analyze that resulting incident from every angle possible to see whether or not the wall of the tank car moved the amount that we thought it should before it punctured, or whether or not the ram hit it the way that we thought that it should. All of those things we can gather and look at afterwards, and then use that to refine the computer models that we have.
And once that's refined, how do you implement that, and maybe how long does it take? So here's a known incident, and we know what the results are going to be, and they may not have been exactly what we thought they would be in the simulation. Is there a transfer of that into the actual design or other safety considerations in real life?
Well, generally, yes. I mean, first of all, you're going to use those models to be able to help develop new designs. For example, the DOT 117 tank car was developed using some of those types of models that were validated at TTC.
Okay, thank you very much. Yield back.
If I
Thank you,
could
Mr.
add
Webster.
one point to that, I would just make that the importance of modeling and simulation capabilities is vital, right, to improving operations. We talked about locomotive performance. You know, we will develop and refine models in real time about the health of a locomotive based on what that locomotive did yesterday, so that we know more clearly what it might do tomorrow based. So I think the importance of updating those models in real time and the value of simulations and the power of advanced analytics capabilities can't be understated.
Ms. Esty.
Thank you, Mr. Chairman. My apologies. We have simultaneous hearings going on. Many of us, Mr. Webster and I, were both in the Science Committee upstairs. So I wanted to actually turn a little bit to that interaction, because that's what we were talking with the National Science Foundation. All of you are talking about technology, and we have a critical shortage in workforce. So I'd like to hear from each of you a little bit on what are you doing and what can we be doing to address those workforce needs, because obviously all these technologies critically rely on an educated workforce. There's intense competition for that. I know for Mr. Risch, the skill level his members need has been scaled way up. GE, formerly housed in Connecticut, but still operations some in Connecticut. For all of you, these are critically important issues, and I can just tell you, Sperry is in my district working on ultrasound technologies. They right now are having trouble hiring enough people to design and deploy and test these ultrasound technologies for detecting rail flaws, and they're in operation all over the world. And it pains me, and it should pain all of us and worry us that we are having difficulty, they are having difficulty hiring enough people and training them for these critically important jobs. It's vital to our national security, vital to our economic growth, and vital to our transportation safety.
Thank you for that question. And certainly, we share that problem at Pueblo, Colorado. And I think there has to be a recognition of a couple of different things that have to take place. One is that at the heart and soul of everything is education. And it doesn't matter what we're talking about or who we're talking about, education has to be addressed. Not everyone who works at TTCI needs to have a PhD. There are a number of individuals and a number of needs that we have for skilled trades, especially, I would say, if you looked and said, what single skill do you need? It would be welding technology. And that's not something that you need to have a 4-year degree for. But we need to be able to encourage individuals to look to these types of careers as a viable, reasonable alternative to a 4-year degree. Secondly, I will say that, as a woman, I have a degree in mechanical engineering. I have a master's in mathematics, and I am fairly unique. When I graduated from the University of Dayton back in 1983, there were 10% of my graduating class was female, and I don't think that that's changed that much, unfortunately, over these past years. Somehow, we need to encourage more women to be able to go into STEM fields. And it can't start at college, and it can't start at high school, and it really shouldn't be limited to middle school. You need to affect these changes much earlier, before girls decide that math and science is too hard for them. In my organization, one of the things that we do is try to work with the local schools to bring girls out and let them meet the fine female engineers and technologists that we have, and we have a number of them, and to make sure that they understand that they can do this. The other thing that we need to make sure of is that we have plans in place that recognize that families happen, and that young men also need to be concerned about families and having a family-friendly environment at work.
Well, thank you. That's very important. And in fact, the President signed 2 of my bills, both of them on women in STEM for this very reason. And I think we need to add not just women, but people of color. Over half the workforce is going to be women and people of color now or soon. And it's just not represented in these fields, and that means we're not going to have enough people trained. So we should have a big intersection between the Science Committee and this committee on these issues. Other folks with some thoughts?
Look, I would echo Ms. Stabler's comments. I think at GE, one of the biggest initiatives we launched this year is what we call 20,000 by 2020. So 20,000 women engineers in our company by 2020. It's a massive effort. And just, I would say more generally speaking, we do see encouragement of STEM education, encouragement of technical education more broadly as critical to the health of our company and to the economy as well. So I fully agree with Ms. Stabler's comments, and something that's important to us as a company, and specifically on the technical side. It is not, and Mr. Tennyson and I were speaking last night, it is not easy to hire talent, especially deep software, deep technical talent. You have to build it, you have to grow it, and they are, I would even call them vital company resources, but vital national resources. So thank you for your interest in it.
Thank you. In my union, most of our members work for the freight rail industry. Of course, we represent passenger workers, and we represent bus drivers and things as well. But when I look at where the women are in our union, it's almost predominantly on the passenger side or in the bus service side. And there's a reason for it. On the freight side, freight trains are not scheduled. They run through towns, and you're just constantly on call almost everywhere in America. Most of our members on the freight side don't even have regular days off. I worked 30 years on call, 24 hours a day, 7 days a week. I occasionally would get a job that had regular days off. Young women who expect to have a family and some demands, and the real world is the young women who have children are expected to be the primary caretaker, or are forced to be. They just can't make a go of it in the freight industry. And until we do something about scheduling, regular on-duty times, or at least a 10-hour call like we've suggested over the years, we're not going to see women in the operating crafts in the freight industry.
Thank you. Other questions from members? Mr. Weber? How much time do you want?
What day is this?
Let me just say, I'm going to have to leave here shortly, but our members will be following up with questions. We certainly would like to know all of the different technologies that are out there. I think that we're making great strides on a number of different safety investments, but we'd like to understand better what those new technologies are, what the priorities are, what the costs and status of each are, as well as the implementation and the impediments that you're facing with some of those, whether it's government regulation or cost or other impediments. We'd like to become better informed as a committee, and we certainly want to take you up on your offer to come back out and see some of those new technologies as well. As a committee, we're going to continue to travel, and we'd invite you to some of those trips on the Northeast Corridor, Chicago, Miami, just to name a few, as well as getting back out to Pueblo. We want to see what the new technologies are and the status and changes along many of those routes. I unfortunately must depart.
Okay.
Mr. Weber, I leave it in your capable hands.
Thank you, sir. I'll
Don't
pick it up.
filibuster too long,
I shan't. I'm
but
from
make sure we get
Texas.
some good information.
Right.
Thank you.
Thank you. Quick question. I want to come back to you, Mr. Tennyson, in discussion over the electronic controlled or electronic controlled pneumatic brakes. Was that the acronym you used?
ECP?
ECP. You said that you thought trains were okay with distributive power. Can you elaborate on that a little bit?
You know, I'd really like to have somebody follow up with you because I am not an expert on ECP braking technology.
Okay.
I am more an expert on computer technology, you know,
Okay.
So I am aware of what's going on in the discussions around ECP.
Oh, okay.
But I do not want to put myself out there as an expert in
No, fair enough. I got you. Now, you also said that you were cutting in your 28, in the answer to, I think, Congresswoman Nasty's question about how, or maybe it was for Ms. Wilson's, because you hit that December 31st deadline. You said something about a 28 through the 31st subdivision cutover. What did you mean by that?
So as part of the deployment of PTC, we are required to go through what's called a revenue service demonstration, where we actually physically implement and start to operate PTC under revenue service. And that's what we would call a cutover when we go into that revenue service demonstration mode. We file a formal process and go through all the associated. And so we filed all those formal processes. We've cut over 31 of the roughly 136 territories that we have to cut over through to revenue service demonstration before the 2018 date terminates. And we track weekly at every week we get together and we track not only the progress in terms of our cutovers, but the number of trains that are actually operating under PTC in that and issues we have with it. We have false brake applications. We have trains that we're not able to originate. We're in essence working through an implementation plan. So,
Okay.
but our commitment is by September now, definitely by December of 2018, to be fully implemented through those roughly 136 subdivisions.
Okay, Ms. Stabler, you have referred to, or maybe it's more than just you have, the DOT 117 tank car standards. When did those come into effect?
I believe, I'd like to defer on that because I hate to say it, I'm the technologist, I know what's in them.
Right.
But as far as implementation, that's something that really is more for the member roads.
2015. Okay, I'm getting a little help from behind you there. Thank you, Ed. Do you have a price of what it costs per tank car to implement those standards?
And then-
Anybody?
Lyndon, that might be you.
I don't have that price. I can get my purchasing person to tell you
Okay.
that, but I apologize, I do not have that
Yes,
price
sir.
tag.
The numbers I have is a retrofitting a 111 to 117 standards about $80,000, and to build a new 117 is
Per car?
Per car, and a 117 is 144,000.
I rounded up to 150.
150. Yeah, you add the ECP brakes, and it's easily
Okay.
under 150.
And then finally, and Mr. Webster, you have questions? You're good, which is the first time in a long while. But anyway, finally, if you could devise an early warning system where you could actually look out ahead in a track with real-time video In other words, that engineer knows what's down that track, 1 mile, 2 miles, 4 miles. Is that doable? Is that possible? Or is that really way too big of an undertaking?
Go ahead, I'll address it too.
I would say that with the detection technology that we have, that's what we're working toward. Maybe not so specific as a single device that would be there to be able to see 4 miles in advance, but instead to be able to understand the health of the rolling stock as well as the rail system proactively. And there's a lot of different ways of doing that that can all come together with the advent of being able to store information as we are today. If you look at the industry, detection technology is certainly a game changer. The ability to store that data and be able to make use of it is necessary to be able to monitor the health. And then finally, the ability to, and this is going to sound very different, uniquely identify each and every freight car and locomotive.
Uniquely identify what kind?
Uniquely identify each one.
Oh,
That's
each and
something,
every,
if you
okay.
look elsewhere in the world, isn't available. We are fairly unique within the globe as far as having freight cars and locomotives each uniquely identified so that we can use that data to be able to make predictions about the health of the car in the future. And everything that we are trying to do is focused on that. But that's where, when you ask one of the things that we could do for help, that's where we really need to take a look at moving to performance-based regulations as opposed to prescriptive ones, and having a waiver process that is
That makes
streamlined.
way too much sense.
We try.
No, I understand. So,
We'd like to have that waiver process streamlined so that we can implement these technologies much more quickly to be able to positively impact safety.
sure, that makes sense. We've been joined by Mr. Lipinski, and we've been going here for a while. Did you have some questions early on, or you want to go to the gentlewoman from Connecticut? She's had a round of questions.
Oh, she had a round of questions? Oh, okay, well, in that case, I didn't want to step ahead. I'll try to be quick. I know you've been here a while, but we were at a... Yes, and as ranking member, I didn't think I should walk out of my spot. Quickly, last Congress, I introduced the Developing Standards for Electronic Shipping Papers Act, which completed the MAP 21 directive to DOT to develop voluntary standards for the use of electronic shipping papers, commonly known as e-manifest. Right now, the HM Access pilot program, which enabled the e-manifest pilot program, has ended, and rulemaking is not moving forward. So I'm concerned that the data is still not centralized, and it's my understanding that there are now multiple apps hosted by different carriers. I know the rail industry has an intense focus on safety, so I'd like to know what our panelists are doing to advance the goal of improving information for first responders and where they see this e-manifest going. Who wants to start?
Well, certainly, you've mentioned e-manifest. That's not the only implementation that's recently taken place to help first responders. First of all, I'd like to thank you for that question, and I'm run an organization called Transportation Technology Center, which includes an organization as part of it called the Security and Emergency Response Training Center. And we've been proud to train over 65,000 emergency responders since 1985 when we opened that particular school. One of the things that has happened to help the first responder recently is an application called Ask Rail, which allows a first responder to be able to understand what materials are on that particular train and how they should respond in the event that they need to be able to access that. How close can they get? What kind of PPE do they need? And that's something that we include in the training classes that we have out at our CERTSI Center. So that's one place where it's a rail industry initiative that has been implemented through our sister organization, RailLink's efforts to be able to provide that information to the first responder.
One on where this moves forward from this point, since we don't have a, do you see any issues with having this data sort of not have one central location? We have different apps. Is that, will it work that way? Does more need to be done?
I'd really like to have our chief safety officer follow up with you on this, because I know they've worked through a lot of these discussions, and I apologize, but I don't feel qualified to really necessarily answer that right here. I could talk to the technology we've implemented to help them, but I think they're closer to the actual process question you're asking.
All right. Let me ask another quick question. I don't want to take too much time. I understand that because of the decline in the movement of oil, that there has been a sort of slowing the, my understanding, maybe slowing the new requirements, new rail cars coming on that have the new required top fittings. Is this going to have any, this going to cause any problem moving forward for meeting the deadline on that?
Well, first of all, I guess, looking back at my colleagues, and we're not really aware of any slowing that has taken place in terms of the requirements. I think that the other things to note is that as an industry, not only, certainly having a stronger tank car is very, very important. But where the industry is also focused is on preventing these accidents in the first place. That's really the reason for Transportation Technology Center to exist, is to make sure that we find ways of preventing problems that would cause a derailment, or detecting those problems in advance of them becoming an issue so that they can be safely remediated. And those efforts, I can assure you, have not in any which way, shape, or form been slowed by any slowing of rail traffic. We are proud to say that since 2000, we've made a 65% reduction in rolling stock and track related types of derailments, and we're only going to be satisfied when we get to zero.
Okay, well, I think that does it. We thank you all for being here today, and that concludes this meeting. Thank you.